install this.
We're streaming.
We're streaming? Are we good? Are we starting?
Well, we're streaming.
Okay.
You might want to turn you off if you
Okay.
want to say horrible things about them.
just snuck in. So basically creating custom web solutions, mostly for Tesla right now, but some other big clients coming down the way. So
You two could go to Mars.
Yeah, so basically creating custom
have a boss that's
mostly for Tesla right now, but some other big clients coming
Anyone
down
else
the
got
way.
something?
So
You two could go to Mars.
yeah, so basically creating custom
have a boss that's
mostly for Tesla right now, but some other big clients coming
Anyone
down
else got
the
something?
way.
Consulting. You two could go to Mars.
Yeah, so basically creating
Excellent.
custom
have a boss that's
mostly for Tesla
We'll
right
see.
now, but some
All right, folks.
big clients.
Anyone else got something? Aaron, come on up.
All right.
Yeah, so basically creating custom
Microphone is on. I think so.
All right, folks. Anyone else got something? Aaron, come on up.
All right.
yeah, so basically creating custom
Microphone is on. I think so.
All right, folks. Really? Anyone else got something? Aaron, come on up.
All right.
yeah, so basically creating custom
Microphone is on. I think so.
All right, folks. Really? Anyone else got something? Aaron, come on up.
All right.
yeah, so basically creating custom
Microphone is on. I think so.
All right, folks. Really? Anyone else got something? Aaron, come on up.
All right.
yeah, so basically creating custom
Microphone is on. I think so.
All right, folks. Really? Anyone else got something? Aaron, come on up.
All right.
yeah, so basically creating custom
Microphone is on. We're ready? I think so.
All right, folks. Anyone else got something? Aaron, come on
Hey,
up.
everybody. All right. Hope you're having a good evening. Hope all the new kinds of jobs and ideas we have are exciting.
Anyone else got
I've been looking forward to doing this talk here. Hope you're having a good evening. Hope all the new kinds of jobs and ideas we have are from San Francisco. Actually came up. I've been looking forward to doing this talk. Hope you're having a good evening. Hope all the new kinds of jobs and ideas. So I'm not like that drive. I've been looking forward to doing this talk. Trying to connect with Aaron. So I'm happy to be here. So I'm not like that drive. I've been looking forward to doing this talk. We're trying to connect with Aaron. So I'm happy to be here. So I'm not like that drive. I've been looking forward to doing this talk. We're trying to connect with Aaron. So I'm happy to be about what they're looking at innovation centers. Everyone's been to innovation center. About what they're looking at action centers. Everyone's been to probably not. So I always have this question. So I've worked with action centers. Everyone's been to so I always have this question. So I've worked with I like to start with these things. We're going to talk today about how you actually do innovation, how you actually make this stuff so you can realize it, so you can actually put it into production so you can get value from it. If you don't get value from it, it's just kind of a mental exercise that you're doing. It's not really real, right? But why now? Why is this interesting? There's a reason why we used to have to do waterfall software development. Who here does waterfall software development now? Wow, they still make you? Obviously, you don't do it because that's what you want to do, but it existed for a reason. People weren't just like, let's figure out the worst possible methodology and make everybody do it that way. It used to take a long time to build software. It would take years to build software. I mean, imagine what you would have to do when you're working these machines. You would have actually, you're old enough to remember the punch card. very early, I remember a punch card. I'm a little, I'm mid-40s. I'm old enough to kind of barely remember it. Now think about having to actually write code there. You don't have a syntax editor. You're literally punching a card and doing the thing. And so in a world like this, where literally you're kind of plugging in things to the wall to test ideas, it took a long time to try something new. And when it took, I'll call it, man, woman years of effort to try any given idea, you should probably make sure that you're planning it out well in advance. It was literally like constructing a building, and you couldn't change it very easily. So that's why, it was just stupid expensive to actually be able to build software. And so that's why, we used to have this long distance between idea to money. Some things have changed in the intervening years. Obviously, it's gotten a little bit easier to test our ideas. And so things change once you move from where we started, which was, in today's dollars, it probably wasn't tens of millions per se, but in the 40s and 50s, it took years and millions of dollars to try an idea. In the 60s, it kind of, it came down a little bit. In the 70s, it came down a little bit more. You can actually build software in something less than a year for something less than $1 million. By the 80s, you could actually build software on a PC for, in 6 months, you could build VisiCalc. I mean, it was getting better. By the time we got to the 90s, when we had the dot-com boom and bust and everything, what was starting to happen is you could build a demo in 3 to 10 weeks and get something done for, $50,000 rather than, $500,000. So now we're starting to see, lots of different ideas that can get tried. You can do pets.com, find out it doesn't work, burn through $10 million. Wait a second, that's not a great example. But you could try lots of other ideas and see if they work. If they don't work, you could pivot and try something different. And over time, this has just gotten to the point where now, in some larger companies, if I am a developer for a retailer, and I have a better idea about how to search for, say somebody is coming in from Florida and they search for a coat, and I want to change the algorithm to say, well, if you're in Florida and you're looking for a coat, that probably means something different than if you're in New Hampshire and looking for a coat. Those two searches probably don't mean quite the same thing. They might, but you could actually say, I've got this idea. Why don't I make the search different from one or the other? Put that into production, see if you actually get better conversion rates on that site, and then if it actually works out better, put that into production the same day. There's companies, Amazon, where you can do this now. There's actually other retailers where you can do this. So what's interesting about that? The interesting thing about that is in a world where you can try out lots of different things, it increases the velocity at which businesses can expand. Because if you can try different ideas, you can understand much more quickly which ones fail, filter through the ones that succeed, or through the ones that fail, and only put in the ones that succeed. And so technology goes from being something that you take a long time to construct to something that you actually can experiment with very, very quickly and throw away if you want. So the other question is, whose ideas are attempted at these different levels? At the highest levels, it used to be just government ideas, and the CEO had to sponsor your project. And as the funding thresholds got to be lower, it started to be just anyone with an idea could try something. And this is actually status quo in some companies. It may not be in yours yet. Who here can just try an idea that they come up with over the weekend and put it in production that week? I saw one hand go up, one hand go up. Do you work for a startup with more than 10 people? No. This is why we like startups, right? But there are large companies where you can do this now. Okay, and a lot of them are organized like startups, which is why there's a book called Lean Startup that talks about this kind of methodology. And I'm going to get to that as we go through the talk. So all that's well and good, right? And we would love to kind of have this ability to be in our career where we can wake up on Monday morning and have an idea. I would actually look forward to Mondays in a world like that. But there's reasons why most of the people in this room didn't raise their hand. And that's because in most systems that we work on today, there is a ton of artificial complexity. There's a ton. I mean, I go look at code bases across hundreds of companies at this point in my career, and most of the time when they ask me, well, why can't we change anything? Why is this so hard? Why does it take 6 months to introduce a new feature to change how the login box works? Why the hell does it take so long? It's because we have all these extra moving parts in software that make it more complicated. Okay? I'm going to get into that a little bit. So the key is, in most of these cases, the marker of a successful developer isn't how much code you write. It's how much code you remove. It's what you can simplify in a system. That's what a lot of microservice extraction is about, and that kind of microservice architecture is about. It's about almost all the really kind of interesting engineering disciplines around software, to me, are about how do we simplify things. Who here uses C#7 today? Who aspires to? Almost everybody that's probably in the .NET world. On the Java side, who was happy when they introduced lambdas in Java 8? Okay, I guess that falls. Look, no Java developers here. Okay. Regardless, I mean, so these new features that they're coming out with are some of the keys to simplification. So when we talk about simplification, a lot of this is in the engineering practices. And so in the talk that I outline, you almost kind of think about this as like a Maslow's hierarchy. Okay. Now, who here does Agile development? I saw some people do waterfall. I'm guessing everybody else does Agile. Cool. Who here does Agile but doesn't do test-driven development? Ah, okay, I see. So this is what we often call, like, there's a lot of names for it. I call it Scrum or Fall, but there's a few other things. It's where you introduce the ceremonies of Agile, but you don't actually have the real parts of it that make it work. And part of this is the engineering practices that are a baseline. If you don't have good engineering practices, which I think test-driven development is one of the key ones, but there's others, the Agile stuff that you do probably isn't going to work longer term. So you're going to run into things that make your code complicated. So I can tell places that have this kind of excess code, because there'll be lots of variables, there'll be lots of excess state. We used to always try to get rid of all the globals, right? But then we introduce like singleton objects and other kinds of things that have this globally accessible state in the system. But any kind of excess state that we have beyond the very little bit that we need actually makes your code more unstable. Think of state like a moving part in a machine. And you need moving parts in a machine. If your wheels did not turn, your car would not go. But if you have the more excess parts that you have, the more things that move in a given system, the more unstable that system becomes. So that's one of the key things that just complicates. I think we all kind of know that intuitively. Null. I think there's some computer scientists that said, Dexter or somebody like that, that one of the worst inventions in software was the invention of null. Why? Why is null bad? I hear a few mumbled versions of it. Okay, somebody stand up, or just, why is null bad? No reference exceptions. No reference exceptions, exactly. I can tell how software has evolved with no reference exceptions because I'll do like code archaeology, and I'll look at a function. It'll be like 30 lines. It'll be if-thens kind of that go diagonal. It'll be if this thing null, if that thing null, if that thing null, if that thing null. And I'm like, I'll bet you that didn't start out that way. But there's probably been like 8 or 9 bugs that have been caught over that period of time. It's kind of what it looks like after the fact. There's a bunch of them. I could do a whole talk on ways that you can screw up your life by writing bad code. But methods that you pass things to that mutate things, I mean, that's a terrible idea. I know there's a few standard functions in the .NET framework that do that, but those are things we could learn how to not do. So those are things that make things complex. So how do we kind of fight this complexity demon? Well, one of which, and I'm not going to compromise, I think test-driven development is an important thing. Not necessarily because you get tests out of it, that's a nice side effect, but because of the way it makes you design software. Every bit of production code should have how it's going to be used, how it's going to be consumed in your head. What TDD forces you to do, it forces you to write a test that helps you think about, how am I going to consume this thing? And what you don't write is extra software for hypothetical use cases. You only kind of write the software for the things that you know that you're going to need. And that kind of provides kind of a minimalism to the classes that you write under TDD. Everything is inherently testable, and everything is useful because at least hypothetically, because you're at least thinking about its consumption before you use it. The other thing that I think we do to fight the complexity demon is functional programming. If you're doing work in .NET and you're using language integrated query, If you're using a lot of the new features in C#7, you'll notice that there's a lot more support in newer versions of C# for immutable properties on objects. Like the idea of a read-only field used to be a little complex to set up. You could do it, but it was more complex. They're making those things default language features. There's a reason, and the reason that is Anders Healsberg, I happen to believe, I don't know this for fact, but was a functional programmer at heart, was forced to build a language C# initially that had to emulate a lot of Java features, which was object-oriented, but he really wanted it to move it away from that. Again, speculation, but I fully believe the fact that language integrated query appeared in 2007, 11 years ago, and it's kind of an integral feature of C# now, I don't think that's a mistake. And the reality is functional programming starts to help you move towards having fewer moving parts in your software. That's a big reason why I happen to think it's something even in your object-oriented code you can start introducing the concepts. So there's a couple differences. We think of OOP. Who here remembers in college having to model like an entire inheritance hierarchy of like animal to mammal to everybody had that stupid class, right? Where this is how we're going to model the entire world using objects, yay, and it's going to all magically work. And then we realized that trying to model the real world using objects, sounds kind of good, but actually introduces a lot of complexity that you don't need. So in functional programming, we're trying to, again, I'm not going to make this all about FP, but we're simplifying and reasoning about the real world, but being very cognizant of how many moving parts we're introducing into our software. Or, there's always this quote, always code as though the person that maintains your code is a psychopath and knows where you live. Like that's, if nothing else, remember this. Like code, over time code bases rot. We all know that. But the more that you can slow that down, the better off we're all going to be. And that gets me to Agile delivery methodology. So we all know what this is. So you're kind of thinking, again, about your consumer. In the engineering practices, we talked about using TDD to think about who is going to be the consumer of the code. Here we're thinking about who's going to be the consumer of the software. And so kind of making sure that our effort is oriented towards somebody that finds something useful, not just doing something to do something, or doing something because it's on a requirement list. Unfortunately, if you remove the engineering practices from Agile, if you're just focused on the morning stand-up meeting, doing the retrospective, doing all, the iteration planning meeting, all these different kind of ceremonies that are involved in Agile, but you're not actually doing the engineering practices, what's going to happen? What happens in that case? Anybody know? You hit the wall. Suddenly, every story takes phenomenally longer and longer and longer to do. Why does that happen? Well, because your engineering quality is low. That means every single change, if you don't have good tests underlying your code, will introduce like just other kinds of things that start to break, other kinds of null reference exceptions all over the place, all sorts of other kind of bad things that can happen. So that's the thing, and you don't notice it at first. And when you start doing Agile on a greenfield project, you're moving fast, all the ceremonies are working for you, but then eventually you find out they stop working because it just takes forever to make any change. So that's why we kind of have to really think about the engineering practices of this stuff. Now it has evolved. Agile is old. What's Agile Manifesto? 2001? Is that roughly? I forget. It's so old that I can't remember the year. But let's say it's 2001 for this example. It's 17 years old. It can vote next year. It's not. The people that like made Agile are all these old men. They're like the wise men of software development. I went through a major car manufacturer last week, actually. I'm not going to name the car manufacturer, but they're all kind of the same except for Tesla. I heard some Tesla people here. They're all based on long production cycles. And even at the car manufacturer, they're talking about the Agile Manifesto. And it wasn't even in the software development floor. It was like in a business room. It's like business has like completely stolen our idea, and now they talk about Agile companies. So clearly it's kind of come a long way. So it's kind of evolved and it's devolved. So what I like is we talk about getting rid of ceremonies. We talk about getting rid of estimates now. scary, getting rid of estimates. Incorporating things like Kanban, limiting work in progress. And almost everywhere I go, like I said, to major car manufacturers, to Microsoft for that matter, I never thought would be like the Agile company, but even they're starting to do stuff like this. Almost nowhere will somebody say, oh no, we're not Agile, we're doing waterfall, except for the 3 people here. But the downside is there's all these kinds of, because it's become this big business, people make SAFe and people have commercialized Scrum, and they've sold Agile as a process without the engineering practices. And that, in order to make it PMO friendly, and frankly, it's kind of taken away from it. And why a lot of people that used to be in the Agile community have kind of moved on to a lot of other things. One of those things is thinking about not just Agile as a delivery methodology, but thinking about continuous delivery as kind of a way to take what you're doing with Agile and actually get value from it more quickly. So who here knows what CD is? A good half the room. Okay, so I just want to know how much detail I need to go into. So imagine you have a unit of work that could have value for a customer. Okay, so maybe not the login screen, but maybe a change of the search algorithm, like I explained before, to make it so that you can more easily find the code that you want in Florida rather than the one you might want in New Hampshire. Okay, so you find that unit of work, you automatically deploy it to a set of environments that can automatically configure, test the change, make sure it doesn't break security, make sure it doesn't accidentally buy you a heavy coat in Florida, whatever. And then deployment of that change to production if the tests pass, like that day, not after the PMO looks at the thing, not after code review, like that day, as soon as it passes all the tests. And you're just doing that continuously throughout the day. And every single one of those changes, when you're doing this well, you're measuring some sort of impact. At the very least, you're measuring, did the thing work? You're continuously testing it, you're continuously integrating it. Everything is trunk-based. You don't have like 7. Who here works in an environment with like 30 parallel branches of hell? I mean, 30 parallel branches. And who here has that routine at the end of the month where you have to merge all those damn things together? Do you like that Friday at 6 o'clock? No, you probably don't. It's enough to make you want to embrace trunk-based development and like make career decisions based on whether they do this mass merge thing or not. So why does it matter? I think the opposite of CD is faith-driven development. I don't know if you guys ever knew what FDD was, but that's what I call it. It's, fuck, I hope it works. Excuse my French. Pretty much when you're not doing CD or at least CI and not having a big set of tests around it, it's kind of like, maybe. Let's see what happens in production when we put it against load that we can't create synthetically somehow. This is the way that you have transparency into what you're doing. You can also you quickly see what caused the problem. So we used to call this a scary concept called testing in production. Now we've kind of made testing in production cool again, but we do it a little bit differently. The old testing in production was, let's make a change to the entire site and have everybody that uses the site have to test the new change. Obviously that's bad, right? So what we do now is instead of doing that, we say, okay, well, we're going to take this new feature and we're going to use our load balancing infrastructure to say only 0.01% of traffic will go at this new feature. And we'll test it in production, but with a very limited bit of traffic. And if that works and it's getting the metrics we want, we start to expand and expose more and more of the overall system to this new feature. We do something called feature flagging to make it work. Some of you may know what that is, but we're able to actually understand what happens. But if something bad happens, it's rather easy to pinpoint what it was. I mean, I've been on some of these other situations where you make a major release, nothing happens for 2 weeks, and then some catastrophic bug happens, and then you're having to spend an entire weekend figuring out what was the source of the thing. Because it's not obvious because you took a major batch of changes, hundreds of changes, and put them to production at once. So you can't know what one thing it was that actually screwed up the entire system. So that's a few of the big reasons why continuous delivery matters quite a bit. So that's one thing. I talk about DevOps as a culture. Who here has ever seen a job ad for a DevOps person? Who here is a recruiter that's posted a ad for a DevOps person? I'm not really going to call you out too loudly. Sorry. I kid. So the way, at least in ThoughtWorks, we like to describe it, is we think about it as an approach, not a role. Okay, I think what a lot of people, when they say they want a DevOps person, really what they want is somebody that does production, release engineering is usually what that means. And maybe it's a longer word, so DevOps is a shorter word, so that's why we've embraced it. But we think about DevOps as a culture. And the reason it's a different culture than what we had before. Prior to DevOps as a culture, which followed on the continuous delivery movement, you would have Dev, who was incentivized, I want to change software as much as I can, because me, literally my job is write software and put it in production. Otherwise, what are we doing? Ops had a different set of incentives. They're like, don't ever put software to production. It may make it so that I can't get my 9 nines of reliability. Two very opposite set of incentives. Now, every now and then, a developer would get in a big argument saying, no, we actually have to release software production someday. And so they invented all these gates and this change control mechanism, all this stuff that made it hard to deliver software to production because something might go wrong and you might actually hurt reliability of the system. And so what we realize, though, when we do continuous delivery is we actually reduce risk of release because we're not releasing a bunch of things at once. We're continuously releasing, continuously fixing things. Again, we're doing the engineering practice, so we're putting the right kind of code in production. But it's really the realization that the incentive around just writing software and getting it to production and keeping servers up has very little to do with business performance. Okay, business performance is, did we get good conversion rate on Gap.com or on some retailer's website? That's what they're buying. They're not buying a system being up. If I get a system in production and all it has is one big button on the screen that goes, yo, or something. Actually, I think there was an actual startup that did that, but aside. If I deliver software to production and it works, but it has no business value, that doesn't matter, right? So it's really kind of aligning the outcomes to things that you can measure that have business results. So what are the products of the DevOps movement that matter? Before the DevOps movement, anybody here that works at Puppet is in town here, right? Right. Okay, cool. So I get to do the local call out to the Puppet people. Yay. I don't know if they're here today, but yeah, so you have Puppet, Chef, Ansible, this idea that we we describe our infrastructure as code, and that we actually have things like AWS and others that allow us to, apparently Azure does this pretty well now, yay. Allows us to describe our infrastructure as code and be able to actually not have to provision things and fill out forms that some ops person will then give us a server in 3 weeks. We can actually just kind of put it out to an infrastructure and see it. We can do Phoenix deployment. Who here knows what that is? Really? Cool. So Phoenix deployment is this idea that rather than, who here has ever tried to do a patch of production code on a server? Okay, so some people had to do real things. Just kidding. What if you didn't have to do that? What if deployment of a server meant you destroy the old one and then just boot up a new one, all the way from install? And so the key here is there's a subtle thing that happens when you're constantly patching your own servers, or especially if you have like multiple, is you start to get what are called snowflakes. Every single one has a slightly different configuration because it's a human that did most of the installation. And what do humans do? They make lots of mistakes. They make a ton of mistakes, subtle mistakes, but they might accidentally not click a checkbox or accidentally not follow the exact routine. Multiply that over 100 or 1,000 or 10,000 different virtual machines in an infrastructure, and suddenly you have Jane or Joe as the only person that really knows how a given special server works. Suddenly you have what's called pets, not cattle. Servers start to have names like your pets. They're not managed like cattle, which is you don't ever name your cattle because they're going to the slaughterhouse. Phoenix deployment helps you not ever do that. Helps make sure that every virtual machine, every container, everything in your overall infrastructure is uniform. And then, of course, containers, things like Docker, things in the CoreOS ecosystem, things like that. kind of standardizing how we put things into production. Again, eliminates a lot of that kind of, everything's a special snowflake configuration bit. Also, just kind of starts taking all the pain out of deployment. So that's helpful. Why containers? Web config, isn't that fun? Who here loves getting in this bad boy of a file? I really don't. So, the idea is, small things. They do a couple different things well. The ideal container is just enough of an OS to do what the service needs to accomplish and no more. Okay, so what does that mean? It means that, if the only things I do is, talk to a network and receive requests from a network, and I can't write to the local file system, I can't do a number of other things. In addition, it simplifies your architecture for one. But one of the really kind of nice side benefits of it is it actually reduces the footprint of what you can attack. If you're an attacker, but everything's in a container and everything's simple, there's much fewer things like there were in the bad old days where somebody would take advantage of some like DCOM configuration on a server that would be, kind of not well known, but there was kind of a big kind of surface area for attack when you have a large operating system with lots of different features, where they realize if you have containers that actually have very few features, but only the ones you need, you reduce the attack surface, which is actually really useful. So that's one of the things we got. Microservices. I feel like every now and then we just kind of take a good idea that we've known for a long time and just give it a new name and invent a new movement around it. Microservices is one of those. We used to call it just have a thing that does one thing well and don't do other things in it, right? Don't mix concerns. Microservices, the key things are small, stateless, ideally, units of business capability that do one thing well. They don't try to mix concerns, and by not mixing those concerns, you actually reduce your complexity in the system. You at least get rid of some artificial complexity. They don't have to be this way. I mean, a microservice is a concept. It's not a prescriptive architecture, but they're typically RESTful interfaces using web standards and protocols. But there are some people that are thinking maybe that's not the right thing, and it's starting to evolve a little bit. I often like to say, especially if they're rendered in functional programming languages, they can often be less than 1,000 lines of code. A lot of the ones in FP can maybe be 50 lines of code, but that's just, F# is awesome. If you want to talk about F# over a beer, let me know. The stateless nature lends itself well to functional programming. And you can easily deploy them in containers because, again, containers are kind of this limited, not a lot of features, operating system. But if you have a microservice, it doesn't need to do very much other than call other services, maybe write to a database or do certain other, provide an interface to some other kind of web front end. You actually simplify it a lot that way as well. Of course, then you get into, serverless. Amazon Lambda, anybody use that before? And there's like a Microsoft specific Azure Functions, yay.
By the way, AWS will be here in June to present more of that.
Good. Good. So plug for the Amazon people. By the way, if you ever see on a job ad, must know AWS, I saw this on Twitter the other day. And it has there's AWS is a collection of 300 tools. There's no way anybody knows AWS. You know little elements of AWS. Unless I don't even think the CTO of Amazon knows AWS for that matter. Anyway, sorry, it's a rant. Serverless, so you don't even think about infrastructure anymore. If you're serverless, if you're writing nano services, you're in Lambda, all that should just be abstracted. You're not even thinking about it. Usually less than 50 lines of code. I don't even know where you would have state in one of these things, so it's a lot easier to reason about. And because you're stateless, why not use functional programming? You're already, if you're not manipulating state, I don't know why you would need variables that change. And they aren't really deployed in the traditional sense. You spin up a container, and as soon as it's done, it's destroyed. So there is no server to maintain. It does run on a server, okay? I mean, if somebody say, well, what does it run on? Water vapor and, flowers? I mean, it's not really that, but there is no server to think about because it's spun up and destroyed as you go. Okay. I'm moving through these pretty quickly. Agile and continuous delivery. So continuous delivery doesn't even make sense unless you're doing Agile. Because what are you putting out to production? If it's, you can put a lot of software out to production using continuous delivery, but the whole idea of continuous delivery is delivering customer value continuously. I don't even know what it would be if you're not doing that. But even more, if you're not delivering customer value, you're not going to get a lot of acceptance from the business for continuous delivery. Because moving into the continuous delivery world means you are changing up the way that production gating works and a lot of other things that have been traditionally the province of PMOs. So if you're just delivering more software, but it doesn't have user value, they're probably not going to get on board. And as well, kind of getting back to the engineering practices, if you're consistently adding bugs through your continuous delivery practice, again, that's going to kind of scare the people away that have been thinking about releases all the time. Plus, I mean, it creates a lot of headaches because now you're spending all your time fixing things if you don't have those engineering practices. So what blocks acceptance? And I'm starting to see less of it. I mean, I might just live in ThoughtWorks world where all our clients want to do this, and there's probably clients that absolutely don't want to do this, but a lot of it's just fear. There's a lot of worry because in prior years somebody might have put something out to production that caused something to blow up, and so you have all these kinds of checks and balances against releasing software. If you have a history of new releases being disruptive or causing quality problems, that tends to block acceptance. Audit concerns. There used to be a lot of auditors that would say, hey, that's great, but we actually need somebody from ops to hit the button for things that can go to production. So I think a lot of this in the last 5 years has kind of gone away. I think most auditors even accept continuous delivery as a thing now that it's a little bit more mainstream. But historically, sometimes you'd run into that. Confusion between the frequency and scale of change. When you're changing something a lot, the scale of the changes tend to be small. And so it's because the changes are small and they're going into production continuously. Two things happen. One, there's not a lot that any given release can impact. But two, and this is the most important thing, is when you do CD, it makes you really good at automation, hypothetically, because you're doing it a lot, you're practicing it a lot. And by all that automation, you actually create stability because you're not creating all these snowflake configurations again. It's kind of created this discipline for us where if we know we're going to production all the time, it causes us to create systems that make that a lot more reasonable. So why should we care? Well, other than we like to put customer value out there and actually have our software do things for people and not just write code, it eliminates the large batch problem, which is, in my mind, there's a lot of software that gets written that isn't useful. Who here has written software that wasn't useful? Good. I'm glad to see a lot of honest people here. Because there's a lot of people, no, wait a second, I wrote the site. No, of course we've been on that zombie project that you knew was going to die, or asked to write a feature that you know is stupid. Well, this provides a way to test against that and say, did we actually get value from the feature that we're writing? At the very least, you can measure software delivery by what actually works, and not just what your project manager tells you. In project management, there's a concept I still laugh at called earned value. Who here has ever heard of earned value? Okay, all the project manager wonks in the room, or somebody that ever looked at a project management course and went, oh, that sucks. You learned what earned value was in the waterfall days. And it was this idea that, well, the project manager will judge based on what developers say is done, how much of the project's done. Which sounds kind of weird because what would happen is that you would be on a track to get to 90%, but 90% really meant 50%. Because the last 10% would take half the time, right? Because you weren't actually putting things in production. You weren't actually testing it. Every project plan I ever saw in the waterfall days had 2 weeks at the end called QA. Remember those? And then you always wondered, well, why? And there was nothing after that. It just assumed everything was going to work. Which never happened. It never happened. It's kind of funny when you think about it in retrospect. So good, we're doing continuous delivery, yay, we're delivering software to production all the time. We can stop being on pager duty because when things break, we just immediately know how to fix it. We don't have to go to work on Sunday. I just watched Office Space for the first time in 5 years the other day, and it reminded me of where we were a long time ago. But there's even more to this. And once we're doing continuous delivery, it enables all sorts of really new, interesting, cool things around lean startup enterprise ideas. So when I think about software, I think about products, not projects. I haven't written a Gantt chart since the day I joined ThoughtWorks. There's my plug for ThoughtWorks. You won't ever have to work on SharePoint, and you'll never see a Gantt chart. Yay, ThoughtWorks. Give me your resume when you're done. We'll talk. But there's a few things I can. You might have to travel. There's the downside. But no Gantt charts, no SharePoint. Yay. But we like to think of working on products, not projects. In DevOps, and I'll get to that in a bit, DevOps by itself isn't that important. What happens, though, is you actually take what happens for the business, what happens for product, and think about merging that with DevOps. What you really end up with is just something I like to call BizOps. And that's basically what the whole company does. So we think about DevOps not being enough. This is kind of a model from my colleagues who wrote this book called Lean Enterprise. And the idea is you start with a company that has goals. It has a mission statement. Is what we're doing the right thing for the company? Okay, again, you can tell I watched Office Space last night. But that starts with some kind of executive vision. You have some goals. Under the goals, you have some bets. I'll get into that in a bit. And then that kind of turns into a product strategy. And you end up with a portfolio of projects that are being measured by the business value that they're creating. And so what you end up not doing, and then you kind of figure out a way to test, are any of these ideas good, through kind of lean delivery. So you're incrementally delivering value, and you're measuring that value. You figure out a metric that matters for every product in your portfolio, or multiple metrics that matter. And when you have those metrics, whenever you go to production using your continuous delivery pipeline, you're saying, did it move the metric? And so if I put in software that moved conversion, meaning like everything, the conversion of when somebody lands on the hit the buy button to they actually complete the transaction. So that's conversion. Sorry about the lingo. If it increases the conversion percentage in a given scenario, I say, oh, good, that hit a business goal, put it to production. If it resulted in inventory, say I'm doing an inventory management system, and by putting this thing in production, it actually reduced the amount of inventory I have to store in my warehouse, which is something that most people in supply planning want. That could be the thing that I'm measuring. The metric, all that matters to the metric is that it's a real metric that a business person would care about. If that metric is moved the right direction by your release, and it could be multiple releases a day, then that's what the measure value, outcomes not output, results not effort, then that goes back in your portfolio. And you just do this cycle over and over again, and you continuously are improving your business. That's really what that's doing. It's taking us as software developers from being a cost to being a producer of business results. We're measuring what we do, just like a salesperson is able to measure their contribution by the revenue that they bring in. Okay, we're now the people that can measure our contribution to the company by the revenue we're bringing in. That matters. I'm going to get to that in a bit. In Lean Enterprise, we talk about this lean value tree. I kind of went into it already, but you kind of break down a vision to goals to bets to promises of value. That's where the metrics I was talking about come in. And then you have multiple pods of development teams that might be developing software to test the promise of value. Promise of value, another way to think of that is hypothesis. And you're driving, what effectively you're doing in that kind of organization is you're testing hypotheses, seeing if they work. And if they work, it stays in production and you continue building software. The key to this is results matter more than effort. Some things I don't care about. I don't care about on time. I don't care about on budget. I know that sounds a little funny to hear, but I don't care about those two things. On time is an effort measure. If I'm running a car dealership and I was measuring my results on how many cars do I wash and not how many cars did I sell, that to me is the difference between an effort measure and a results measure. Okay, and whether it took 2 hours or 2 minutes doesn't matter because the metric is wrong. Results are about choosing the right metric. So that's my rant on that. So is the monolith dead? What's the revolution going to be? I think it is. I think it is. We're not going to be writing big monolithic systems anymore. for most things. Code bases of millions of lines of code to tens to hundreds of lines of code. That's what we're moving towards now. From big iron to disposable infrastructure. There's very few new clients doing new work, and even stuff that we're being brought in for to take care of older infrastructure. I actually talked with a guy at a major car manufacturer who's putting mainframes on the cloud. It's literally putting the equivalent of a back system on cloud infrastructure through an emulator. Now, of course, they have to put in all sorts of sleep commands and do all sorts of things to make sure it runs acceptably slowly for things that depend on certain kind of transactions taking a certain amount of time. But still, it enables them to get off of actually having to own the big iron, so they can put this on like an Azure or a AWS. Projects where success is defined by on-time delivery to results delivery. Okay, even if it takes a little longer than the deadline, if the results aren't good, it doesn't matter. So now we're talking about results being measured by business metrics, not by completion metrics. This is a more important thing. Software developers have always been, up until the last few years, an organizational cost. They look at your salary, they look at your benefits, and they go, God, how can we not pay that? I know it's kind of mean, but CFO, I've seen the CFO do this, and like, yeah, we got a lot of developers. God, how do we have fewer of them? You know what they don't say that about is salespeople. Salespeople, because of what they do is directly tied to revenue, in a lot of companies where that's a function, they're like, can we just bring in more salespeople because we'll get more revenue? What software developers are seen as a driver of profitability, and they are, which is why the ones at Google and at Amazon and some of these companies that have put these things in place are like, yeah, here's the money, just go make us profit, right? More and more companies are going to see things this way. Okay, and that's really kind of key for you guys, because with that, again, it enables you to convert the idea that you have over the weekend into something that will drive something for the company that you're working on or the startup you're working on or anything else. And then even if the company doesn't recognize you, you're seeing the impact of what you do. Every day, every week, you're working against something that you feel is real and not just something that's an arbitrary goal from some pointy-haired boss 3 levels up in the hierarchy. Okay, that's kind of the ideal that we want to get to. Okay, it's been a long talk. When you leave here tonight, I recommend going to watch Simple Made Easy by Rich Hickey. It was an InfoQ talk he did about 2011, so how many years? God, that's 7 years. But he talks about a lot of the concepts when I think about code quality. He's kind of my patron saint of code quality. He's also the inventor of the closure language, of functional language. But it's probably one of the best talks about just thinking about how you think about code quality in a world where you're trying to reduce the number of moving parts. What Simple Made Easy means is it's actually easy to create artificial complexity. It's a lot harder to create systems that are simple but lack that artificial complexity, that don't have more moving parts than you actually need. And then the books to read. So these are your assignments for next week. I won't be testing you, but maybe Rich will. Lean Startup by Eric Rice was one of the first books in the last 10 years that when I read it, I actually got out a highlighter and highlighted all the, like, oh my God, this has like changed the way I think about things. Because this is kind of one of the first books that talked about kind of always using metrics, measurable business metrics to judge whether what you're putting out there in a startup, be it software or anything else. I mean, it could be a food startup, doesn't matter. But kind of looking at your business in terms of hypotheses and then testing those and seeing if they work, bringing down the cost of the test, but then once it goes to production and you know it works, then scaling it. He talks about that a lot in Lean Startup. So a couple of my colleagues, Jez, Joanne, and Barry, so 3 of them, got to know Eric, and so we wrote a book called Lean Enterprise that is about how do you take these ideas in Lean Startup and how do you apply them in a company like Intel or some other company that has legal restrictions, has a lot more at stake. I mean, if I start up my startup tomorrow and it catastrophically goes bad, yeah, it's going to be bad. You know, it's my personal net worth might be impacted, but I'm not bringing down Equifax. You know, it's you know, I'm not screwing up an entire company that, you know, 10,000 people need to be employed by. There is a properly higher amount of you know, kind of thinking about how do you do these techniques in a larger company where, you know, a mistake even in a continuous delivery world could matter a lot. So in Lean Enterprise, talk about how you structure lean value trees, like I talked about before, but also what some of the audit concerns are. So Joanne Molesky, she was actually an IT auditor before she contributed to this book. And so that's one of the reasons that we kind of appreciated her contribution, because otherwise, this, you know, somebody at an Intel or something like that could say, well, you know, that lean startup stuff, that's great for your 50-person company. It doesn't work for my 500,000-person company. Continuous delivery, Jez Humble, again, was the major author of this one, but this was kind of the book, again, promoting some of the things we've been doing in ThoughtWorks for a while, which is really trying to drive the industry to this continuous delivery mindset. And then one of my friends, Sam Newman, wrote a book called Building Microservices. So at least there's one book on here that wasn't written by somebody at ThoughtWorks, so yay. And then I wrote a book, but that's just because my publisher makes me put the book on there. But anyway, those are really the four I would care about other than mine. And thank you. That's it. Any questions? I put a lot out there.
Better ask him questions because we've got to have time to pass out around.
Yes?
Change management. How do you get this into an organization so it works and it sticks?
I think the best way to, it's a really good question. Because I do this a lot. And I find it's easy to get a CEO or a CTO excited about this stuff. There's no CEO on the planet that goes, God, I really just want to pay for effort, not results. You know, so you start there, right? They definitely want to get things done, and they've been wondering, why do I spend? I mean, I know companies that spend $1 billion a year on people that write code. $1 billion fucking dollars a year on coders. And the CEO can go, I don't know, I think I get value out of it. My stuff runs, but I can't, you know, for this level of investment, I ought to be getting more. So getting the C-level is actually not hard. Those people kind of easily fall in line. There's a whole bunch of middle management that we have to, there's a name for it. We call it the frozen middle, which is people that are an ops VP who's incented by keeping 5 nines going, right? And lots of people like that have incentive systems that work against this kind of thing. They're paid by reliability. They're not paid by business results. They're paid by getting the project done. Procurement departments that are, who here works in IT services or contract placement? And who amongst you loves vendor management? Oh, they all left already. They got bored. But yeah, I do some work negotiating deals, and all these vendor management people, they're like, yeah, business results, lower the hourly rates every single time, right? You know, which is, and you think, why do they do that? Do they just not care about quality? Do they just want, no, literally in their comp plan, it's get costs down, get average hourly rates down. They don't get their bonus unless that happens. And it's very hard to move, you know, when somebody's paid to want to think a certain way, that's hard to change. And so what has to happen is you get the CEO excited, you get the CTO excited, and then the conversation is, we need to get strategic alignment and actually change how you're incentivizing people. And that change has to happen, because if you have a bunch of incentives that are designed to make it, to do this hard, they will make it hard, and it will not stick until those incentive systems are changed. Which is why we've literally gotten to the point where even in ThoughtWorks, we created groups that help you reorganize the way you do software. Because ultimately we found we were trying to do all the CD stuff. I mean, we didn't want to get in that business, but we had to, because otherwise companies weren't going to adopt it. Or they would adopt it for a while, and then they would, you know, just inertia would set in, and they kind of go back to their old PMO ran ways. Yes?
So when you initially launch something, so the very first delivery is continuing from any previous delivery. How do you employ all these techniques for that first time?
For the first time, well, this is where the most overused word in the industry, so much so that it's, if you watch the Silicon Valley, HBO show, it's completely ruined it for us. But the MVP is the, yeah, exactly. The minimum viable product is the first thing. The idea is how quickly can you get to feedback? And when we think about an MVP, it's very different than, I guess, if you're doing a small startup or Apple, but figuring out how quickly can we get something in the hands of somebody where we can start showing value or at least showing progress that will materially move to value somehow. And that, you can do that in 6 weeks sometimes. I mean, I think if you get creative about how you frame what the MVP is and figure out a way to do it in a low stakes way, that's usually kind of the best way to get started. And then you're continually iterating on that, figuring out, okay, great, it worked for this user. Now how do we get the adjacent type of user to also have it work for them? And this could be for commercial software where you're writing something for a major e-commerce website or something like that. Or it could be even for internal software where you're trying to say, okay, well, maybe the metric is, do we have within the, I'm just going to make up something, but within the HR Expensify system, do they actually do the reports on time or not? Or how quickly are they able to get through the things so they waste less time? You figure out a metric that matters where you get real feedback, and then you start improving on that. Does that answer your question? Cool. No more questions?
Any
Yeah.
thoughts on how to apply some of this to something that also is delivering hardware?
Yeah. And so a lot of hardware is controlled. So as far as how you would continue to deliver things that are literally hardware, where like you're 3D printing something and it's a production process, you can even do it with, I've heard of it being done in that kind of context. I actually had a client that, there's a case study on it, I can say who it is, but if you look up germ zapping robots in ThoughtWorks, we actually had what we did was actually put in a continuous delivery project to the robots. Now, it was hardware, but we were doing delivery on the software that ran the robot. And literally there were tests. I actually had to get a robot shipped to India because it was a project we were doing half out of India, half North America. And they would, literally in order for the test to pass, the robot would have to go through certain motions, and they would measure using sensors did the robot actually go through the motions. So you can actually set up physical hardware tests as part of your CD pipeline to get to some of this. Does that answer a little bit? Cool. Anything else? Yes.
Half-form idea, so I'm going to throw it at you.
Sure.
When you're dealing with a code base that gets delivered, customized to multiple customers, is there any strategies to, in that situation, to avoid copying and pasting and
you probably have some
that problem. I need help.
you probably I have this vision of a switch block that says switch case client A, case client B, case client C. There's some patterns, strategy plugin patterns that can help you get out of some of that in terms of just design patterns. If you can figure out a way to do some sort of like modularity around, certain, so if certain things and how it differs tends to go together. So it could be, let's say it's a system that does e-commerce somehow, but you have different strategies per customer on how you would, say, handle the intersection of zip code and a certain type of item of clothing. You might figure out a way to have a plugin module for that interacts with a certain set of interfaces. So that the common part across all the different clients is changes less often and changes there apply to everybody. But then specific client things are in their own microservice. If you can architect it that way, again, I'm just kind of thinking out loud, but that's how I've seen that kind of thing done before. So you can avoid this kind of, massive switch case things that have lots of repeated code all over the place. Because with the case you're talking about tends to be one of the biggest causes of cut and paste code, right? Where literally you have the same algorithm that slightly differs, but you have to kind of cut and paste it like 9 places. And then, oh God, did I get it for all 9 clients? Oh shoot, now I got to tell, yeah, that's a nightmare. So that would be the kind of strategy I would employ. Or just force all your clients to use the same thing and tell them not to be different. That might not work as well. Yeah?
You talked a lot about top-down direction and measurement of value. Have you thought, or has there been any discussion of bottom-up, or from developer value. I think a lot about like justification of salaries, and people are like, oh, we can't pay them that much.
Mm-hmm.
But if there's generation of value, how is that measured? It's measured from the top.
Yeah, so what's funny, it doesn't happen, like you don't walk in, create the new search algorithm that made $1 billion and go, okay, give me my $10 million 1% share. It doesn't quite happen like that. But when in industries where it became easier to measure more quickly, a good example of this was, remember the flash crash? People doing high frequency trading? That was the first time I've ever heard of a programmer making $1 million a year. Was, they would be literally taking a cut of whatever trades they were making. So like all things, financial services and I guess pornography are the two like early adopters of all technology. But they kind of adopted this, and it very quickly became a competitive market because the people that had the better algorithms that could drive better value became well known. And bidding wars started happening to those people. But it doesn't magically happen. There's no company that's like paying $100,000 for a developer now that they invent the thing and they willingly just give up a check for $1 million. I mean, I wish that happened. Now, does that answer the first part of your question?
Yeah, that's essentially a different framing of the argument, or the question is, why aren't the developers getting $1 million salaries?
Oh, there are.
Well, I mean some, but there's a proportion, I guess.
The more people do this, the more that will happen. The problem is most of the industry is not doing this. Most of the industry is, I see them every damn day. A lot of them are still in waterfall. They call it agile, but it's like 2-month iterations, and it's leading up to a major release at the end of the year. I'm like, all you've done is adopted the ceremonies, and you haven't really done anything. So there's a lot of that out there. But what will naturally happen, and you see this in some of the digital native companies, you're more likely to do those kinds of numbers. I don't know that people at Google or Amazon get millions, but more of them do, especially ones that can kind of prove value. Like at Amazon, if you are in a group and you create that kind of value, you're probably going to get stock pretty soon because they can more easily measure it. Is that at Nike yet? I don't know. Again, not to pick on Nike, I just know they're a big company here. So. Cool. Any other questions? No? Okay. Then I'm going to give up the floor to our person.
Yeah, the prize committee. Great.
Prize.
Let's just do this and go to Thirsty Lion.